Welcome to part 2 of the notes. We're going to start digging into object-oriented programming in this video. We've already seen at this point a few different kinds of objects, strings, lists, dictionaries, all stuff that you're familiar with already, but we might sometimes not be able to do everything we need to do with just these types that we know about. And so fortunately, Python gives us the ability to create our own kinds of objects. As an example, let's look at Twitter. Twitter's pretty successful, arguably. You can broadcast a short message on Twitter called a tweet. If you want to write a program that's like Twitter, you would probably need to represent a tweet somehow in some way, including who wrote the tweet, when was the tweet created, what are the contents of the tweet, how many likes does it have, so on and so forth. Now, you could store a tweet in a list, just like this. So, the name of the person who made it, the date, the content itself, the number of likes. Or you could use a dictionary alternatively. So here's your dictionary. The key of user ID gives you the name. The key of the created at gives you the date, so on. And you could pass these objects around, and that's one way you could do it. And this wouldn't be wrong, and it would function the way that you wanted it to. But there's a catch. And the catch is that there's a really big problem in that nothing really prevents you from just deciding to mess up this format completely. So, for example, let's suppose you're doing a list, right? One option is you could just completely mess up the list's format entirely. You just decide, you know what? Heck, I'm going to put the number of likes at the front. Your code wouldn't recognize there's a problem here because all it's expecting for a tweet is a list. It doesn't know that, lists are supposed to be in this exact format. You also could take a tweet and just ruin it. You call pop to remove one of the elements, and now suddenly the number of people who like the tweet is just gone, and you don't have enough information to actually fill in the tweet. And the rest of your code will still try to work, even though your tweet is now completely malformed. If you're using a dictionary, you could make an entry that just straight up doesn't have the date. It's not there. You could add a new key value pair that shouldn't be there in the first place. You just decide, we're going to throw in units as centimeters to our tweet, just for fun, no particular reason. Furthermore, with a list or a dictionary, you have nothing to enforce your 280 character limit. So you could just decide, let's just have our message go on forever, even though no tweet is actually supposed to have that. Now, everything I've been complaining about is protecting against errors, and it's not something to do with, is this correct? In other words, you could use lists and dictionaries and get things to work correctly, but you would have trouble every time mistakes are made along the way. So a better idea is to make a new type specifically for tweets, and the way we do this is by defining what's called a class. And a class allows you to specify exactly what is the structure of the data supposed to be, and allows you to control what operations can be done on that data. So let's define a class. A class is a block of code that defines a type of data. You're probably actually familiar with some of these already. Something like int, str for string, lists. They're all classes for all of these things. If you have a class and it's called whatever, x, any object that is of that type is called an instance of the class. So for example, if we have the class of integers, the object 3 is an instance of that class. It is a kind of integer. Now, an instance of a class doesn't necessarily just have a single piece of data. You can have a whole bunch of stuff inside of it. And each piece of data that's part of an instance is called an instance attribute. So if we have tweets, and there's a class for tweets, a single tweet instance could have an instance attribute for its content, its user ID, its date, number of likes, and any class that you decide you want to make can have as many attributes as you want, and they can be whatever types you want. You can have integers, strings, other classes as attributes of the class that you've made. Now let's see how this actually works in Python. First off, we pick the name of the class. Typically this should be capitalized and probably a noun, otherwise it might be a function you're trying to make. And so in this case we'll pick tweet. Then you should write the docstring so that people who are using this class understand how it works. And we're looking for here a description of what the class itself is and what are the attributes inside of it. So a tweet is a tweet, like in Twitter. The attributes, we're going to have user ID, which is who wrote it, created at, the date it was made, content, what's in the tweet, and the likes, number of likes it's got. Now, below the doc string, you can declare the type of all your instance attributes, and the syntax for this is the attribute name with a colon, then the type. So the first few lines of the tweet class could be something like this. User ID is a string, created at is a date, and here date is something we'll grab from a library, so we don't have to like worry about how do we track dates. We'll use Python to do that for us. Content's a string, likes are integers. Now, as we discussed in the last series of videos, this syntax is really mostly for Python programming tools, something like PyCharm, to go and check these attributes for you. This is not the same as other languages. Unlike languages like Java or C, this code that's here doesn't actually really do anything. It has no effect on how the program runs. You can scrape all this away from your code and it will work just fine. But it's good practice to include these because if you want to start using some of the automated tools, they may be looking for this information in order to run. Now, right now this looks a little bit redundant, right? We've now defined user ID in two different places, which seems kind of messy, but it's important to understand the distinction between these two things. Attributes up here are mostly meant for the user to understand. If you're a person who's trying to use this tweet class, you probably want to know what the heck is it doing. Down here, this port is more for the automated tools. They need to be able to read in exactly what type of attributes we're looking at so it can actually do analysis, bug detection, and so on. Now, after just writing what we have up above in the class body, we've defined a type, and so you can make an instance of it. So here, I'll just grab the parts up here, throw these in, and now I can do tweet equals tweet. And look what's going to happen. So date we got to grab from our library. We got a tweet class. We've now described what a tweet class is, and we can make one. So we have an instance of our tweet class. And right now there's no actual data that gets stored in here, so nothing really happens. Okay. Now, if you try to do something like tweet.userid, print tweet.userid. Oh no, it doesn't have an attribute called user ID because it hasn't actually been set up or anything. And even if I had the code that is here, that wouldn't make any difference. So if we want to actually have a user ID for a tweet, we need to do something, because right now this is all we got. We have a tweet and it's just a blank box. Great, not too helpful. In order to set up the instance variables for any class, there is a special method you use, and it's called, in Python, __init __. In English, initializer, I call it constructor. I'm pretty sure they are interchangeable terms. But here is what this is going to look like. So I'm going to steal this and put it in over here. All right, let's break down what I just did. We have a new function. It's a special function, and anytime you see these double underscores, that usually means that something, like Python uses this for something specific, and in this case, anytime that you are constructing a new tweet, this function is always run, no matter what. What are the parameters we have in here? First off, the first one looks kind of weird. It says self. What's up with that? Basically, any initializer / constructor has a very first parameter that refers to itself. By convention, we just call it self. This is true in other languages as well. And in fact, if you don't have this in Python, most code checkers will complain at you and say, why did you not include self? So here is how you would use this function. We have, who, when, what for the tweet. Let's determine how this initializer is going to work. So we have our library. We're going to make a new tweet. Let's steal this tweet and put it over here. Our tweet doesn't actually, our line here where we set up our tweet doesn't actually mention __ in it, because it's a special function that is going to get called automatically. Also, even though we have 4 parameters we want to work with, self, who, when, and what, we're only passing it 1, 2, 3 things. you never have to pass self. It's just sort of assumed that that's going to be the first thing always there. So it's, and this is to basically get the ID of the instance that you're setting up. So basically what you're doing here is shown in this little MS Paint diagram again, where we're trying to initialize our tweet with the tweet itself. So we have self. Who is our name Giovanna, when is a date that we've set up, and what is hello, because that's the first tweet that we're doing. Now, the initializer, its job is to fill in this blank, because right now this blank is not really doing much for us. So we want to actually, add in user ID, for instance, in here. So let's suppose that we want to do that for our tweet object. This means you're going to need to do an assignment statement somewhere. But what's going to go on the left side? Well, we need to make a new variable, but if you just write user ID equals the thing, bear in mind that this is a function. It's in its own frame, so as soon as you leave that frame, it's sort of useless to us, right? So you need to actually put the variable in the new object, not just in the constructor initializer. Fortunately, self allows you to grab the object, and you can go into it by writing self followed by a dot. So our assignment statement is going to be self.userid is, and what's it going to be? Well, we know who it is. It's who, because that's who wrote the tweet, right? And so here is what our initializer method is going to look like. Let me put that over here. So after you have set up a new tweet, the very first thing that happens is the user ID is set to whoever you put in. When it was created at is set to when it was put in. What the content is what you have given it. And the number of likes is straight up going to be set to 0 right away. So now when I run this, you can see now our tweet class has a little bit more stuff to it, right? It has a function, it takes in some parameters, and now when I try to make a new tweet, we go into the initializer function, we have our self set up, we have who, when is a date, our self is the tweet that we're trying to set up, and what is hello. All right, so we want our tweet instance to have a user ID of the name, the created at to be this date, the content to be hello, and the number of likes to be 0. And now importantly, when we leave here, remember everything that's in blue is going to vanish, right? So the stuff that's on the right side here is the stuff that's going to stick around, which means as soon as I go to the next step, boop, this date still sticks around, even though the pointer to it, the little arrow to it from the initializer has disappeared. Our tweet class is still there. T1 now is referred to this instance of the tweet class, and it has all of these specific attributes. Cool. And this is the MS Paint version of what I showed you. Now, with everything set up, you can go and grab those attributes if you need to access them. So, for instance, we already have tweet.userid, or sorry, that should be a t1.userid. Yep. We can get that. We can get the, let's see, the content, and we'll do the likes. And so as I skip through everything we just saw, zoom a little bit. There we go. User ID, the content, number of likes. They're all stored by doing t1 dot, and t1 is the name of our instance of a tweet. And we can grab the specific user ID, contents, likes, whatever data we want to. Now, note that we let the client code choose initial values for who, when, and what by passing arguments. You do not generally give the client control over the initial value of likes. We saw here that likes is going to be 0 no matter what happens. There's nothing you can do about that. So this means anytime you make your own initializers, you should decide which are things that you want the people using your class to be able to set up, and which are ones that you say must always be a certain value. Now, what happens when you create new objects? We kind of saw a little bit of this, but let's dig in some more. Our initializer function is different from the ones that you're familiar with in a few ways. First off, the first parameter is always self, and you never have to pass it. It's just assumed to be there from the side of when we were creating our instance. And when you are building your class, you need to mention that this is part of your initializer. By convention, you also don't specify what the type is for self, because it's sort of obvious what type is a tweet. Well, it's a tweet. You don't need to say that twice. This will show up in all the methods that we're going to be writing for our tweet class. You may also notice that the return type of the initializer was none. However, that seems to be weird, right? Because over here, returns a none, but aren't we doing an assignment here? T1 is tweet of a thing. So this is because when you create a tweet, it doesn't just cause you to run this function. It actually does three things. First off, behind the scenes, kind of without telling you, it makes a new tweet object for you. It then calls this function with the self being equal to this new object that was created, along with the other three arguments. The last thing that the init function always does is return the new object, and this is where that actually happens, not from the call itself. So even though I didn't write return tweet or whatever inside of my initializer, you still can set T1 to be equal to the tweet. So once we've defined a tweet class, how many tweets can we make? There's no limit, right? Each one is an object. It's an instance of the tweet class. So, if we make 25 tweet objects, how many contents do we have? Well, there's 25, one for each of them. So this is why we call it an instance attribute. We don't share the same content between all the tweets. Each one has its own version of content, user ID, date created. So a class you can think of as acting as your blueprint or template for what this object is going to be. When you define a class, you've specified what are the attributes every single one of these is always going to have. Every tweet has the person who made it, has the date it was made, has a number of likes. So this means you have a commonality, a common structure on all the data of that type, which is the whole purpose of doing this. So we have our new type now, which means now we can write functions that use tweets or create tweets. So here's some examples. Let's like a tweet. Here's a function like, given a tweet and an integer, record the fact that it received that many likes. Presumably the number of likes has to be 0 or greater. And so if we do, make a tweet and then we like it 3 times, the number of likes it has should be 3. The code is really simple. You add the number. Retweet, create a copy of the same tweet with a new user and a new date. So, given a new user, a tweet, and a date, we return a new tweet, and the tweet is given the new user and the new date, and you copy over the content from the old one. Makes sense? Now, it's certainly possible to do pretty much anything you could need to do with your tweets by writing functions. There are some downsides of doing this, primarily that all of these functions are considered separate from the class itself, and so anytime that you want to be using any of these functions, you have to import them from any programs outside. Now, think about how you used to use strings before you knew about what I'm talking to you about right now. You probably did some stuff like this. Your word is supercalifragilisticexpialidocious, and you did a word count of how many times I shows up, and hooray, it shows up 6 times. Now, it'd be super nice to use a tweet in this way, but right now we can't, because our current class doesn't actually do anything other than store some data for you. Now, we can change this by moving functions inside of a class, and this makes it called a method instead of just a function. So in other words, a method is a function inside of a class. We have already seen a method. It's the one that we just made, this one. And it's a special kind of method because it does a bunch of extra stuff behind the scenes, and it's essential, otherwise you can't actually make instances of your class. However, any function that operates on an instance of a class can be converted to a method with the following. First off, indent it so that it's actually part of the class. So right now, if I wanted to add a method here, I need to make sure it's indented on this line, new method. Because if I instead put it back, it's no longer part of the class. So putting it here, method, here, regular function. Secondly, the first parameter of a method needs to be an instance of the class, and it should be called self. So let's suppose you decide liking is going to be a method of your tweet with the following code. So here's a method of our tweet. It's called like, and it's going to do what we mentioned before, add some likes. And we'll do that right over here. So now when I run this, you can see that a tweet class is going to have two methods available. One is the initializer or constructor that actually sets things up, and also you can like a tweet. Yeah. Okay. Cool. Now, notice that the code here that we used for like is slightly different from before. Before we did, where was it? Tweet.likes plus equals n, and so tweet was the parameter of this. This time we have self, so we use self.likes, just like in the initializer. Now that like is a method of your class, you don't have to import it separately. As soon as you've imported tweets, you can now like them as well. And you do this the exact same way that you would to access a attribute. So if I want, I can do all this stuff here. Then I can do t1.like, and we'll do let's like something 100 times because we're feeling really generous, and we'll see what happens, right? Okay. We've already seen all this stuff from before, so I'm just going to skip to the part that we're interested in. Okay, so our tweet has 0 likes so far. Let's go change that. t1.like with 100. I now make a new frame because we've gone into a method, which is a function. Self, you can see here, is referring to the same thing as t1. And because a class, this class, is immutable, when we make changes here, they are going to stick around. So self.likes plus equals n. So here's our self.likes. Let's add n to it. 100. And now, hooray, our new tweet has 100 likes. Aren't we popular? Now, notice that when we did tweet.like of 10, this is not as epic as our 100, still only passed one argument, right? Even though like has self and n as two different parameters, we only gave it 10 or 100. I didn't have to do t1.like t1 comma 100, right? So the whole point of this is that when you use the dot notation, putting a dot in front of the name of the instance automatically passes self into the method. This is kind of like how you were using strings before, right? When you did, word.count of I, you didn't do word.count of word comma I because, you just passed the string that was to be searched for, in this case, I. How does Python know which one you're searching through? Well, it uses the dot and sees, oh, you're looking for this word. If you had done name.count, it would look through name because it's to the left of the dot, which is the whole point of the dot. And count is just like a method that we just did. It has one parameter called self and another parameter, in this case, the string you're looking for. So a method is really just a function that's been tied to a class in some way, and you can reference it directly from the class without using an instance. So for example, the method count is part of the string class, so it's actually str.count. This means you can call it directly the same way you would any other function, and so these two are the same thing. You can do word.count of I or str.count of word comma I, and they are equivalent. So similarly, we can do something like that for our tweets. Our intro tweet is Diane saying, "Welcome to this course on this date." You can do intro.like of 10 to give it 10 likes, or you could do tweet.like and pass it intro, the one that you're doing the liking to, and 10. They are the same. However, even though these are both available to us, you can clearly see which one's shorter, right? So you can guess which one we probably use more often. At the same time, in object-oriented programming, the object itself is like the most important thing to us. So every time you use dot notation, it's to remind you are working with an object, in this case, this one, whether it's a piece of data or you're doing an operation or anything like that. There's another important technical reason that we use dot notation, but we'll wait until probably the next series of videos, I think, to talk about that. But for now, we just saw that methods in Python are a special kind of function, and everything that you've already learned about functions is going to apply to methods as well. However, this begs the question, how do you know when something should be a function versus it should be a method? Well, here is the main design difference. Methods are part of the class and form the basis for how others should be using this class. They're put it together, which means anytime you have the class, you have the method as well. Functions, which are separate, must be imported separately before you use them. So this sounds kind of like, functions are quote-unquote less useful since you have to do extra work to do them, so why not just make everything a method? Well, when you're designing a class, you're not just making it for yourself. You're making it for anybody else who might potentially be using that class. And you have really no idea what people will potentially want to do with the class that you've made. So there's no way you can write every method that could possibly ever be useful. Even if you tried to do this, you then have now the problem of anybody who wants to use your class has to read through all this stuff to try to figure out what all of the things that are there and which methods are actually useful. So here's a good rule of thumb. When you write a class, write methods for behaviors that you think will be useful for most people who are using that class. Functions should be used for operations that people who are using your class will have to implement themselves for specific needs. So there is no right, wrong answer that's always going to hold for everything. It's a design choice, which means you have to use judgment. Now, we said the initializer or constructor is a special method. This is actually a technical term in Python and is used to describe any methods that we don't call using the regular syntax. So we didn't actually write underscore in it. It just happens as part of the steps for making a new instance of a class. Double underscores indicate special, and there are other ones that are out there. So if you define a method called __str, it gets called anytime you print an instance of a class, which means you can decide how you want a class to be represented by text. So for example, this would allow you to write print t1 as this. And I think we'll probably see in this class how to implement this exactly. So just a couple last minute notes. In this course, we'll usually just say attribute instead of instance attribute. It's shorter. However, there are other kinds of attributes that you'll learn about later. Also, method is just, we're going to always call a method, a function inside of a class. Dot notation, like t1.like, is something that's common in multiple programming languages, not just in Python, and it is called dot notation elsewhere. And the fact that not just for our tweet class, but every class in Python, anytime that you are making instances of the object, it's always the case that you are creating that new block of data for everything you do. So whether you're making a tweet or you decide to make a Facebook post class because, I don't know, you wanted to do that, don't ask me. Every time you make a new instance of one of those classes, you now have another copy of the variables / attributes that are inside of them.